All right, welcome students. We're going to look at more with graphing systems of equations. Now in the last class we saw that when we have a system of equations, we can graph the two lines and look for the intersection point, and the intersection point gives us the solution to the system of equations. Today we're going to see that that doesn't always work. There are two other scenarios we can find ourselves in, and we want to be able to recognize those scenarios and figure out what to conclude in those situations. So let's take a look at two examples. First, let's solve y equals 2x minus 1 and y equals 2x plus 3. Now here we have a system of equations. Let's go to graphing these. Now both of these are already in slope-intercept form, so we can graph them that way. This first one has a slope of 2 and a y-intercept of -1. So we can start by plotting that y-intercept. And the slope is 2, so we go up 2 and to the right 1. And we can continue up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. If we want points in the other direction, we can go down 2 and to the left 1, down 2 and to the left 1, down 2 and to the left 1. And we have a graph that looks like this. Now let's take a look at the other one. Here we've got y equals 2x plus 3. The y-intercept in this case ends up being 3, so that's going to be our starting point. And the slope is 2, so we're going to again go up 2 to the right 1, up 2 to the right 1. We can also go down 2 to the left 1, down 2 to the left 1, over and over and over. And we can draw the line that goes through those points. Now we know with the system of equations, after we sketch the lines, we're looking for the intersection point, but we can't see any point where they intersect. Now it might be possible that if we continue them out really far, they're going to get slowly closer and closer together, and they'll intersect somewhere, just not in this area that we have here. However, we know that they're not going to intersect. If we look at the slopes of these, both of them have a slope of 2. These have the same slope, and lines that have the same slope are parallel. They are never going to intersect. And when two lines never intersect when they're parallel, and these are the lines we get from a system of equations, because they're never going to intersect, we conclude there is no solution. So in a situation like this, our final answer would be no solution. There is another word that we can use to describe a system of equations like this with no solution. We call it inconsistent. Something that's inconsistent is something that just is illogical, it doesn't make sense. And it doesn't make sense to find a solution here because they are never going to intersect. So that's just another word that we can use to describe the situation. Let's take a look at the other example of something different that can happen. All right, solve y equals -1/2 x plus 2 and 2x plus 4y equals 8. Again, we want to solve this by graphing, so we're going to need an xy plane. Here we are. Now, the first of the equations is in slope-intercept form, so we can just jump straight to graphing that. The y-intercept is 2, so we start at 2 on the y-axis. The slope is -1/2, so we're going to go down 1 and to the right 2, down 1 to the right 2, down 1 to the right 2, etc., etc. If we want to be accurate in the other direction, we can go up 1 and to the left 2, up 1 and to the left 2, etc., etc., etc. And then this gives us the line for the first equation. All right, now let's take a look at the second one. The second one is not in slope-intercept form, 2x plus 4y equals 8. We could put it in slope-intercept form, but I want to use the intercept method because I want us to get practice with these different methods. So for the x-intercept, we know we need to let y be equal to 0. This gives us 2x plus 4 times 0 equals 8. Now 4 times 0 is 0, that term's going to go away. So we have 2x equals 8, and if we divide by 2, that gives us x equals 4. And so we can plot that. 4 on the x-axis is right here. Okay. Looks like that might be the solution, but let's continue, because we need both of these lines. To find the y-intercept, we know we need to let x equal 0. If we do that, we've got 2 times 0 plus 4y equals 8. Now 2 times 0 is 0, that term goes away, so we're just left with 4y equals 8. And to get y alone, we can divide by 4, giving us y equals 2. Now if we plot that intercept, 2 on the y-axis is right here. And if we try to connect the dots, we notice something interesting. These two equations graph to the same line, which is crazy, something we've never seen before. All right, they don't look like they'll do that at first because they're different equations. However, they're just different ways of writing the same relationship, and they give us the same line. So we need to interpret this. Because they're both the same line, any point on this line happens to be on both of the lines and is a solution to both of the equations. So every point on this line gives us a solution, and because there are infinitely many points on that line, we conclude infinitely many solutions. When we end up having two equations that give us the same line, our final answer is going to be infinitely many solutions because there are infinitely many points on that line that are then on both of the lines and that are solutions to that system of equations. There is a word we can use here to describe this situation. We say that these are dependent. And kind of the joke I like to make, when you've got two friends and they're dating and they never separate from each other, they're always together, they're dependent on each other, kind of like how these two lines are always right next to each other, they're never separated from each other, there's no distance in between them. So we say that these are dependent in that situation. So just really quick, there are three different possibilities we can have when we're solving systems of equations. The first is the one that we saw the other day, when the lines intersect in one point and there is a single solution. And we write something like x equals 2, y equals 3 for our solution. That is the first situation. They intersect at one point. The second situation is that we have parallel lines, and in that case we just say there is no solution. And the final possibility is that the two equations give us the same line, in which case we say infinitely many solutions. If you want a little bit of practice with these sorts of problems and identifying which situation you're in, take a look at the example problems that are linked below, and you can get as much practice as you need.